Okay, so let's wrap up this particular part of this module. We're talking square roots again, and this actually goes for any even root. But let's focus on square roots because they're a little easier to look with and just think about what multiplies up to something rather than 4 or 6 times. But let's take a look at their functions. And again, from previous work, we already know that there's some issues. Square roots and negatives aren't really good. And right here, we're usually talking about a principal square root. So that's a lot of little nuances. So how do we work with them in functions? We just pay attention, right? We're aware of those little rules. So for starters, we're asking to find f of 3. So under function notation, what I'm being asked to do is x is equal to 3, and I'm putting it inside of the function. So there's my function. So this turns into the square root of 2 times 3 plus 3. And then treating this as the order of operations that it is, I first have to figure out what the radicand is before I do any square roots. So we get 6 plus 3, that's the square root of 9, so we get a value of 3. So this guy, the input, actually matches the output. Why? Because of what all happened. So when you put a 3 into this function, you actually get a 3 as the output. Graphically, also what that means if the 0.33 is on the graph, is we'll talk about in the future. But for sure, right, hopefully that's a nice review of functions, its notation, how to evaluate them, with this new concept of radicals, in this case square roots. How do I find f of 11? Well, the same way. This time we're asked to put 11 into the function f. So I'm going to go to my function, and I'm going to replace that x with 11. So again, this is an order of operation. 22 times 11 is 22 plus 3. We get the square root of 25, so that's 5. So f of 11 is equal to 5. Graphically, that means 11, 5 would be on the graph if we were graphing. So again, we're evaluating. F of negative 1, well, we're replacing, right, 2 and negative 1 plus 3. Order of operations would say do that radicand first. Square root of 1 is 1. So f of negative 1 equals 1. Or as an ordered pair, we're talking about negative 1, 1 being on the graph. So we're just evaluating functions. Nothing new here, just we're doing it in the concept of a square root. F of negative 6, well again, this is asking me to take my function and put a negative 6 in there. When I do that, I get negative 12 plus 1, which is the square root of negative 11. This guy has all kinds of problems. First of all, the square root of 11 is not nice. Second of all, we have a negative in there. And so what number can you square and get negative 11? Well, as we've seen, we can't, right? There's not a real number, so this is not real. And then last but not least, f of 2. When I put that into the function, we get 2 plus 3. That's 4 plus 3. We're looking at the square root of 7. And this, unlike this one, is real, right? This actually does exist. I think earlier in another video we found this to be like 2.6. I think it was like 575, and it goes on forever. So be careful, right? Square roots and negatives are bad. Those are the ones that are not real. So we have to worry about domain. And then things that are not nice are just not nice. That doesn't mean they don't exist. They're just not nice. So this point, right, this function would have the point 2.6575 on it. All right, so that point actually exists. We could actually graph it, put it on the graph, and go through it. All right, so how about we move on to another one? There's that first round. Second round, I have a new function. We're going to call it g. Be careful about what's the radicand, because we have the square root of x minus 2. Notice that whole part is under the radical, and then we have a plus 1. So that plus 1 is not underneath the radical. So we're going to read this as literally this whole piece, right, plus 1. So that's going to help us when we evaluate. So g of 0, well, we're being asked to put 0 into the function. So I'm going to get 0 minus 2 and then plus 1. Well, 0 minus 2 is a negative 2. And then what we've just reviewed over here is that the square root of a negative number is no good, right? This is not real. So it doesn't matter if I even add 1 to it. This is not real. If I'm not real, you can't add 1 to it. You just can't do it. So again, right now the answer is not real. G of 2, well, again, I'm going to my function. I'm replacing that x with 2. So we get 2 minus 2, right, square root plus 1. This is the square root of 0 plus 1. The square root of 0 is 0, and so we get a 1 out of that. So g of 2 is 1. G of 18, well, again, I'm going to go to my function, and I'm going to replace that x with 18 now. 18 minus 2 is 16. Square root of 16 is 4. Now we can add the 1, and we get 5. So for this function, g of 18 is 5. All right. G of 31, well, we're going to go to our function, put a 31 in there, and then subtract the 2. That gives us the square root of 9 plus 1. All right, and be careful, this isn't like the first one. The square root of 29 actually does, in fact, exist. That's just not nice. Using what I know the square root of 25 is 5, and the square root of 36 is 6. So the square root of 29 is going to fall in between these guys, and probably closer to the 5 since 29 is there. So my estimation would be something like maybe 5.3, on and on forever. But of course we can go to our calculator. I know you guys can't see what I'm doing here, but I'm just going to come over here, and I will use my calculator in this case, right? So we got 29, and when I take its square root, my calculator's giving me, yeah, it was pretty good. This is like 5.38516, yada, yada, yada. Of course, what are we doing with that? We're adding 1 to it now. So if we add 1 to it, we're talking about roughly 6.38516, and it goes on forever. This is, again, it's not a nice number. It's irrational, but that's how I would calculate it. So be careful between something that just doesn't flat out exist versus something that's just not nice. All right, and of course, there are some values that are nice. So I was kind of nice to you in some situations and a little mean to you in others. But again, please make sure you're showing your work. You'll notice I didn't really cut to a calculator until I really needed it, which was like over here. And then I even gave myself an estimate. It's very doable. So with that, since we're talking about functions, let's revisit the concept of domain. Now remember what domain is. This is the set of inputs. What values of x can I put into the function and make it true? And you can see just from our exercises, we have to be careful because sometimes I can put an input that doesn't give me a valid piece of output. It's okay here, right? The 2 is fine. I could put it in and still get a valid piece of output. But it's the negatives that cause a problem. And I think that was one of our red flags we talked about back in chapter 7, that we do not want to have the square roots of negatives. So if I'm trying to find the domain of something, right, like let's say f of x equals the square root of 2x plus 3, then what I have to make sure of is that the radicand, I don't want it to be negative. So I want to make sure that it's at least greater than 0, right, positive, or at a very minimum that it's equal to 0. And so we have, basically we have this thing to solve. So if I subtract 3 from both sides, we get that, divide by 2, and we get that x is greater than or equal to negative 3/2. So the domain for this function, right, in interval notation would be from negative 3/2 to infinity. So negative 3/2 actually gets the 0 started, and then I can put anything in there and go. And you can kind of see that's what happened here. Notice 3 is greater than that, right? 11's in that interval, negative 1's in that interval, and 2 is that interval, and we actually got a value out. We tried putting a negative 6. Negative 6 is not in that interval, and we had some problems. So finding domains of the next function, g of x equals the absolute value of x minus 2 plus 1. Well, again, that's not the problem there. Here's the problem there. I need to make sure that whatever is underneath that radical, it remains positive, or at least equal to 0. Adding 2 to both sides, we get x is greater than or equal to 2. Interval notation, 2 to infinity. So notice 0 is not in that interval, we had problems. 2 is in that interval, we're okay. 18 and 31 were in that interval, we're okay. We actually got values out. So more on domains later. That's going to impact our graphs. So let's move on to cubed roots now that we've handled square roots.